Hello good people, I'm going to talk about electron configurations of ions. But before I do that, a bit of revision is in order. Here on the right hand side I have magnesium and nitrogen. I invite you to write down what type of ion they are likely to become. I also suggest that you analyze the scenario in terms of number of protons, number of electrons, and the charge. And if you are feeling adventurous, I also invite you to write out the electron configurations for magnesium and for nitrogen, as well as the electron configurations for the ions that they will become. Pause the video and have a go. Alright, I'm going to start with magnesium. So magnesium atom in its ground state has 12 protons and 12 electrons. This means that the overall charge is 0. There are 12 positive particles and 12 negative particles. Is the magnesium atom going to become a positively charged cation or a negatively charged anion? Magnesium is a metal, and recall that metals tend to lose electrons. They tend to lose particles of negative charge, which means I will end up with a positive cation. So let me write that. I have my magnesium. Here's my reaction arrow. It will become a positively charged cation and it will lose 2 electrons. Now, I have said that the magnesium will become a positively charged cation. What will be the charge of this cation? There are a couple of ways I could approach this. Firstly, I'm going to do it in terms of number of protons and electrons present. I'm still dealing with a magnesium, therefore I still have 12 protons. But I have lost 2 electrons, therefore I only have 10 electrons. This means that there are 2 more positive particles than there are negative particles. As a result, the charge is a positive 2. I need to indicate that this magnesium ion is actually 2 positive. So I'm going to write in the upper right corner 2 plus. Another way to approach this is to use my understanding of the periodic table of elements. All of the elements in group 2 will end up giving a cation with a 2 plus charge. Alright, so I can say that a magnesium atom will lose 2 electrons to give a magnesium cation that has a 2 plus charge. Okay, let's look at nitrogen. A nitrogen atom has 7 protons and 7 electrons. Overall, it has a charge of 0. It is neutral. What will happen to the nitrogen atom? Will it become a cation or an anion? Nitrogen is a nonmetal. Nonmetals tend to gain electrons and become negatively charged anions. So nitrogen will gain a certain number of electrons. How many? This will depend on the valency of nitrogen. Recall that if I start from left to right, the valency is 1 for group 1, then 2, then 3, then 4, and then we start going backwards. 3, 2, 1, and 0. The valency for all elements in group 15 is 3. Therefore, nitrogen is going to gain 3 electrons. And that will give me an anion of nitrogen. What will be the charge? Again, we are going to analyze the situation. Nitrogen still has 7 protons, but now it has 3 extra electrons. It has 10 electrons in total. Or we could say that it has 3 more negative particles than positive particles. Therefore, it will have a charge of -3. And up here in my chemical symbol, I indicate that by writing a 3 followed by a minus. Now I can read this as a nitrogen will gain 3 electrons to become a nitrogen anion. Fair enough. Now let's look at the electron configurations of these atoms and ions. I'm going to start with magnesium, and then I'm going to do the electron configuration of the magnesium cation. Once again, I invite you to pause the video and try writing out these electron configurations yourself. Alright, even before I start writing out the electron configuration for magnesium, there are a couple of things that I already know. Magnesium is an s-block element. That means its last or outermost orbital will be an s orbital. Furthermore, magnesium is in period 3. This means that that last or outermost s orbital will be a 3s orbital. Alright, I need to accommodate 12 electrons for magnesium. So I have 1s2, 2s2, 2p6, and 3s2. And that takes care of 12 electrons. What about the electron configuration of the magnesium ion? Well, the magnesium ion only has 10 electrons. Or I could say it has 2 electrons less than the actual magnesium atom. So let me write that out. I still have 1s2, 2s2, and then 2p6. And that takes care of 10 electrons. Let's do the same for nitrogen and the nitrogen anion. Nitrogen is a p-block element, which means its outermost orbital will be a p orbital. Furthermore, nitrogen is in period 2, so that outermost p orbital will be a 2p orbital. Okay, nitrogen has 7 electrons that I need to accommodate. So I start with 1s2, 2s2, and then 2p3. That takes care of 7 electrons. What about the electron configuration of the nitrogen anion? The anion has 10 electrons that I need to accommodate. Again, 1s2, that's where I start, 2s2, and then 2p6. 3 more electrons than the nitrogen atom. Note that the magnesium cation and the nitrogen anion have ended up with the same electron configuration. In both cases, the outer s and p orbitals are now complete. Electron configurations with the outer s and p orbital that are complete are stable. This means that a magnesium cation is more stable than a magnesium atom. The same is true for the nitrogen. A nitrogen anion is more stable than a nitrogen atom. Recall that when atoms become ions, they mimic the electron configurations of noble gases. So what noble gas are the magnesium and nitrogen ions mimicking? Both of these ions have 10 electrons. This means they are mimicking the noble gas with 10 electrons. And if I look at my periodic table of elements, neon has 10 protons and therefore 10 electrons. So let me write out the electron configuration for neon. And I'm going to do that here in the middle. So here's my symbol for neon. Neon has 10 electrons. So I start with 1s2, 2s2, and 2p6. Lo and behold, we have ended up with the same electron configuration that is shared by the magnesium and nitrogen ions. The general trend in the periodic table is that the cations will end up with the electron configuration of the previous noble gas, while the anions will end up with the electron configuration of the next noble gas. In this case, the nitrogen anion ended up with the electron configuration of the next noble gas, which is neon, and the magnesium cation ended up with the electron configuration of the previous noble gas, which is also neon. This means that if I was to look at sulfur, the anion of sulfur would end up with the electron configuration of argon, whereas an anion of potassium would also end up with the electron configuration of argon. In summary, in an effort to achieve a stable electron configuration, metals will become cations, thus mimicking the electron configuration of the previous noble gas, whereas nonmetals will become anions and thus mimicking the electron configuration of the next noble gas. That is all for now, and I will see you on the flip side.